The floating point is a number representation which is magical and also floating. In this episode, we are going to focus on the floating point data type. We're going to describe what is the floating point in a simple manner. Actually, we can describe it in a few sentences for you to understand. If you don't know what floating point is by now, then it's just another data type. And also, do not worry, because there is a recent paper which was released which said that the top libraries like NAS3, WRF, which are used for forecasting and science and benchmarking parallel computers, all had, and citing from the paper, potential lurking problems, which means all did not deal perfectly floating points. For example, they had division by zero, they had rounding, which were undetectable by the software. They have a constant rate of events which indicated possible issues with floating point. So we are not alone here, and with that let's move on to describing what floating point is. So floating point is a data type just like integer, short, string. So as we know, computers use bits, 0 and 1, volts. Floating point can take the form of 32 bits or 64 bits. In 32 bits, it's called single precision, and in 64 bits, it's called double precision. So let's take a number and describe how floating point would describe this number. Let's take 54.53. So what do you see here? You see digits 5453, and you see a point. The point is in the middle. This means that the floating point can describe this number by describing what are the digits that are in this number, 5453, and where is the floating point? It's floating after all. So the floating point is at index number 2. This is exactly, you have just described the floating point data type. The floating point data type is composed out of what is named a significand. The significand is simply the digits that you have. If we had 54.53, then the significand is 5453. And also the floating point, which is called the exponent. So the significand is the digits, and the exponent is the dot, the point. What is the index of the point? And with this, you have just described the floating point, and you can understand all the issues that are coming with it. For example, it's not a real number, right? Because we have a limit on the bits. We have either 32 bits or 64 bits. This means that we have a limit on the number of digits that we can store, or where we can say where is the floating point. Also, when we take the 32 bits or the 64 bits, we need to decide how many bits are going to describe the significance, the digits, and how many bits are going to describe the exponent. In single precision, the significant is taking 23 bits and the exponent 8 bits, and in the 64 precision it's just taking more bits. Single precision is getting from 10 to the minus 38 number to 10 to the 38, so it's very big, and the double precision is from 10 to the minus 308 to 10 to the plus 308, even larger numbers. So if you ask yourself why when I add floating points, I might not get a precise answer, but by precise answer we mean that we have a rounding error of 0.000001. This is because we cannot describe 1 divided by 3 in a real number, because it's 0.3333333, etc. And we have a limit on the number of bits that we have, so we cannot really represent this number in a floating point. However, the floating point is still useful for us. So what you can do is you can just think of which app am I developing. If I'm developing a scale app, a weight app, a running app, a health app for users, then I can just round this. If their weight is 54.000001, I don't need this 01, I'll just round it, no harm. If you're developing a spaceship or a car or a weather forecast, things where the floating point might aggregate, then it could be very important for you. Not only spaceships, right? Also things where there could be an aggregation of the floating point. If you deal with nanotechnology, okay, this is where it's very important. People are dealing with nanotechnology, with biology. So the scale is very short. You need this 0.00001 to denote it. If you're dealing with money transactions, also it's important. So to sum up, floating point is just another data type like integers. If you have a finance application, then you could just use integers and denote the money by cents. But this would have its own issues because if you need to convert the money to other currency, then it would be problematic. But this is one solution. There are some efforts to have a real number system, to a symbolic number system, to actually denote that 1 divided by 3 is 1 divided by 3. But this is slow and complex. Therefore, we have the integers, the short, the floating point, and all these numbers. There is also big decimal you should look if you really need the higher accuracy. But the more accuracy that you get more complexity and more slowness in the application. So you should take this trade-off. Because floating point is good, it's good for fractions, for real numbers, when you don't need this 0.0000 accuracy. So this was floating point. It's composed out of the significand, the exponent, you describe the digits, and remember that all the top libraries of math and physics also have their, actually any library almost that would include a floating point would have rounding issues. So you should take care of it, and this was a brief summary of what is the floating point. I hope you enjoyed it, I sure did. See you next time.